Hey, hi everyone, how are you? So, we're back to this Global Hack Week. Here's Jocelyn.
Hi.
How are you?
Hi, hi. Good, good. We're here.
It's great. We are we are super excited about this. You can tell, but I have to admit, I am kind of tired because it is too late for us. Like it's midnight for Jocelyn. It is 1 a.m. in the morning for me. But yeah, let's get this started. I see some comments from Rookie Rookiehan. So says hello everyone. G3X says hi Roberto Haisling, and I post the check-in link. So please do not forget to register. And this time we will invert the order. So you are going to start, Jocelyn. Is that correct?
Yeah, that's correct, Alberto. That's correct. I'll be solving a medium problem. I mean, I think it's one of the easy medium problems. Still, I find it kind of challenging for me, and it is related with linked lists. So, let me. Do we want to jump right into it,
Yeah,
or do
sure.
we have
Let's get
anything else?
started. Like
Perfect. So let me share just my screen. Uh, I want
7
to
a.m.
see.
for G3Act.
Wow, that's. I mean, that's
You're so
early.
committed into learning.
Always eager to learn. There it is. Perfect. So I chose this problem mainly because when I read it for the first time, I haven't solved it yet. So this will be kind of like a warm up for my interview. As on my interview, I'm expected to solve like easy, medium level questions, but mostly medium. And I've heard a lot that they use linked lists like very often. So I saw this problem and it was on the top of the list, and I was like, okay, why not take it like as a challenge to solve it on the live stream. So let's begin by reading the problem, and we are told that a linked list is said to contain a cycle. So, first of all, a little bit of context. The problem name is cycle detection, and it was under the linked list category. So, for all of the people that are joining right now, we are solving this medium level question, at least for data structures. And it basically says that a linked list is said to contain a cycle if any node is visited more than once while traversing the list. So right now, as I'm reading this, I know that this information will be quite useful, at least later. So, oh wait, I have my keyboard in English. No, Spanish. Ah, there we go. So let me start by typing. Wait, doesn't change to English. There it is. So I will start writing my notes as always. And I found the first sentence really useful because it's basically telling me the definition of a cycle. So an important definition to know in here is that um, a linked list contains a cycle if any node is visited more than once. So that means like basically plus one. And as an input, we are giving, it says that we're giving a pointer to the head of a linked list, and we have to determine if it contains a cycle. So as an input, we have pointer to the head of the list, and we have to determine if this contains a cycle. And in this sentence, it basically telling me what my output will be, which is basically one or zero. Um, but we are also seeing over here that my function returns a boolean, so that 1 and 0 will be a boolean value. So let's write output, and the output will be basically um, bool true if it contains cycle, and bool false if doesn't. And I think that is all the important information, at least for the problem. And now we want to dive into some of the examples that we have over here. So we have an example, and we have that our first element, the head, refers to the list of nodes 1 to 3. And the last element is null or null pointer for C++. And we basically are showing that the numbers in the list are the node numbers, not that they're
Okay, yeah. I didn't want to interrupt because I wasn't sure if it was me or it was Jocelyn, but yeah, network, you know. Let me try to contact Jocelyn to see if she can rejoin. But very first, I need to plug in my computer. Like right now, it's going to turn down. So give me a second for that. Okay, computer saved now. And let me contact Jocelyn. Okay, now she is in. Right. Hey, we missed you.
hey, I'm back.
No
So what was
worries.
the last thing I was saying?
The last thing I heard of you was that you were okay. I think now my connection is not that good.
Yeah, I'm not sure if
Or
it is me.
can you hear me?
Yeah, yeah, I can hear you.
I am back. I think.
I'm not sure if it is me or you. No, I'm not sure.
Okay. And your screen too.
Yeah, let me share screen and we'll see if my internet does well. There we go. Let me edit. Perfect. So I think my internet is okay now. So let's continue where we left things off. Okay, I think Alberto left us for a while, but He will for sure be back later. So let's continue. We already have our input and we already have our output variables. So our last step, final steps will be to basically solve a handwritten example that we have over here, or at least try to understand it in our solution. So we have that the head basically refers to the list of nodes, and I was saying that the numbers that are shown here are the node numbers, and it is not the data that they contain. So we can observe in here that we don't have a cycle. Why? Because we don't see any number that is repeating itself. So it's basically zero, and we have to return, in this case, false. And then on another list of nodes, we have one, two, three, and one, and then no pointer. And we can see that there is a cycle here. Why? Because we are seeing one repeat itself twice. And another important thing to note in here is that the elements in my example are not, they are not node values, not node values. These are just basically the positions of our linked list, and that is how we will be basically spotting our cycle in here. Because if we see that our elements basically traces back into the last element or into the middle element or any position of our linked list, then we will for sure be having a cycle in there. And then as a function description, which we have it over here, we have the has cycle function, and we only want to return true or false depending if it has a cycle or if it doesn't. And as an input parameter, we have a node from a single linked list, and we have the first element, which is basically a reference to the head using pointers. And actually, it's kind of confusing in here because it's telling me that as an integer, I have to return 1 or 0, but my function is Boolean. So in this case, I will probably ask the interviewer, like, hey, can you clear this out? What do I have to return? Do I have to return like true or false, or do I have to return like 0 or 1? And usually they will clear this out for you. For this case, I will just try with true or false. And in case if it doesn't passes any test case, then I will circle back to 0 and 1. And just the final things from our question. This information, I don't usually read it on interviews, as we don't, for this problem at least, we don't care what our main function does. Why? Because we only want to know if this linked list has a cycle. Like, I don't care how the linked list was filled or how many elements, how are we counting the number of elements, how are we assigning like each element's space and memory. So that's probably why it's hitting over here. Like, you don't want to confuse yourself like by reading through that. What it is important is to actually see the constraints that we have. In this case, we only have a constraint that's basically the size of our linked list. And usually, if there are more constraints or things that you want to know about important variables that you have in your algorithm, then they will be listed in here. And usually, you also want to ask your interviewer like if there are any extra constraints or if you have another extra question about things that might go wrong with your algorithm. And as a final example, you actually want to go through this. Why? Because this is a nice diagram basically explaining what a cycle is and how each element is passed as an argument for our function. And here's the explanation. It's saying that the first list has no cycle. Why? Because we only have one element. So right now, I know that my first step for my algorithm will be check if my head is null. And then after that, there's another example where we actually have a cycle. and we are returning 1, which is the head. So to think of an approach here, I'm actually thinking something related to using 2 pointers. Why? Because we want to keep track of elements every time we go back to our linked list. So I will just write each step of the process. So as a first step, I want to initialize my 2 pointers. And we want these pointers, we actually want them to be different, because to detect a cycle, there is usually this logic. I'm not like inventing this logic right now. This is actually something that is stated at least for cycle detection that I have studied before on another problems. It's actually pretty common to have these types of questions. So for an approach, when you want to detect like the cycle of not only linked lists, it could be any other type of thing, you want to picture yourself as if you were like in a race. And I don't know if some of you know the story of the rabbit and the turtle. And basically, like, the turtle goes slower, but it goes like at a constant pace, and the rabbit goes like really fast, but then it's just like not moving at the end. So we want to take this approach here in order to detect cycles. Why? Because we will be initializing like our 1 pointer will be basically the slow pointer, which will be kind of like the turtle, and then the fast pointer will be the rabbit. And we want to initialize them at different steps. So one probably at step number 1, and the second one probably at step number 2. And they will have different speeds, and they will be moving. And when we reach like an equal point between both of the pointers, then that means that we have reached a cycle. I know it can sound kind of like too much right now, but let me see if I can uh, code this up. Like, I know the logic, but sometimes I get confused when I'm trying to solve it. So first step, initialize my 2 pointers, and then I want to use 2 pointers that are basically one slow and one fast speed, which will be basically representing the turtle and the rabbit, which is it's kind of it's kind of cute if you think about animals in that way. And we want these pointers at first, and both initially at the head. Why? Because we're starting like at the beginning of the race, if you want to picture it like that. Initially at the head of the list. And after that, we want to clarify that the slow pointer will move 1 step at a time, and the fast pointer will move 2 steps at a time. Yep. And after we have our cleared out logic of pointers, then we want to move to actually traversing the list. So that will be like another sub step over here. That will be basically traversing the linked list. And we want to move slow firstly with our first pointer. So we want to move slow as our first approach. And moving slow means that we want to move 1 node at each time. So it will be basically like 1, and then 2, and then 3, and then 4, and we will be moving like step by step. Move slow, 1 node at a time. And then we want to move fast, 2 nodes at a time. There it is. And then after that, we want to detect our cycle. So this step will be actually called detect cycle. And how are we planning to detect our cycle? Well, as I mentioned before, once like we get, for example, the slow pointer to reach the faster pointer, then that means that we have a cycle, and because it is like within the loop. So to detect a cycle, I'm going to write if there is a cycle cycle fast will eventually. It is too much. No, it's not too much. You'll see once I'm coding the solution that it's not like very complex. Like I think it would just be like for loop and then just checking like updating the pointers. It will be very straightforward. So if there is a cycle, fast will eventually catch up to slow. So imagine if we are picturing the turtle and the rabbit. If there is a cycle, well, my fast pointer will eventually like reach the slow one. Why? Because it already like circled back again. So let's imagine that the rabbit like already completed the round and the turtle is still like stuck in the same place. So it's just like circling back, and that means that we have a cycle over there. Then on the ninth step, that will be in case we don't have a cycle, which will be basically the opposite. So if fast reaches the end of the list, then we have no cycle and we can return false. And that is all. I think those are all the steps that we need. Um, I can sum it up to use two pointers, slow and fast, traverse linked list, and two if else. One if for the first pointer and another one for the second pointer. Yep. Let's move to our function. I think I lost it. Yep, we're here. So first step, just basically we want to check our base case because this is actually an edge case. This will always be true. If we don't have like any other elements in our linked list, then that means that we can return files directly. Why? Because if we don't have like more than one element, then there must be like no cycle. So if my head, which is basically this element, so if my head is equal to null pointer, and null pointer in C++, I don't know if it's the same in other languages, but at least this means that it's kind of like similar to null, but null pointer just saying that that is like an empty space in memory. So nothing is actually in there. It's just like an empty space in memory that is not taking like anything inside of it. And in case our first our first element is null, then we want to return false. Why? Because we have no cycle. If there are no elements, then we cannot have a cycle. So I will just write it in here for you to remember. No elements means no cycle. And just like that, we already have like the first part of our algorithm, which is actually pretty straightforward. And then after that, I will move on to the next part. So our next part says that we have to initialize two pointers. So to initialize two pointers, we're going to use our single linked list node. And we're going to call one fast, which will be equal to the head. And the other one will be called slow. And the reason why I'm making them equal to our head, because if we remember the story of the turtle and the rabbit, it means that we want them both to start like on our starting line. And our starting line will be the head of the linked list, which is basically in this diagram in the left in here that says one is our head. So we will always want to start like at the beginning. And we have our fast pointer and we have our slow pointer. And after that, I want to go to traverse the linked list. So to traverse the linked list, I can use different like how do I say like flow methods, but I will be using a while. loop, as I think it will be better if we're trying to check like different conditions. And our conditions are basically like checking if one moves slower or if one moves faster. So for that, I'm going to write while. Usually, I like to use the autocomplete function in here, as it already like makes the nice tabs of everything I want to do, and I don't have to be writing it all by myself. And inside our while, we will basically start with our first function, which is our first condition, which is the fast pointer. And we want to check if fast is not equal to null. Why? Because if the fast already reached the end, then that means we have nothing else to move on to. So not equal to null pointer. Again, null pointer is just basically an empty space in memory, so it means like it doesn't have nothing. And we want to check, that is an and we want to check if our next element after moving fast is also null. So how do we do this? For some of you that are already familiarized with data structures, such as, for example, binary trees or linked lists or anything else, to move through our nodes, we do this like arrow thingy that just basically points to our next position in memory. And in this case, we want to check if that is equal to the next node. And let me see if there is the constructor is over here. Oh, wait, I cannot use them. Yep. So usually hacker rank problems give you like the constructor of your single linked list node, or basically like the data structure that you will be using. In this case, I'm seeing that next is one of the attributes or parameters for my single linked list node. So that's why I can access it over here, because it's basically part of this class. Sometimes they're called different, sometimes it's just like the same names, just something that you want to check before like actually writing the solution. And we want to check if the next one is null pointer too. So in here, just we're just basically checking that nothing is null. And once we go into, we want to check, we want to move slow. So how can we move slow? Well, just going one node at a time. So how do we go one node at a time? Just simply by doing my slow will be equal to the next one, And just like that, I move slow by one step. And the second one, what do we want to do? We want to move fast, right? So move fast by 2 steps. So what are we using here? We are using our fast node that we declared earlier. And how are we moving 2 steps? I mean, if we already moved one step in here using slow next, then that means that we can do the same for fast next. And it's just as simply as writing next again. And that means that we are moving like 2 nodes at a time. And to end this condition, we basically want to check if slow and fast are the same. That basically means that we have detected a cycle. So we just write a simple if condition. If slow equals to fast, then that means we have reached a cycle and we want to return true. Why am I getting an error on my if case? Oh. Let me see. If slow equals fast, return true. Oh, you're right. I'm forgetting the. Is it? Oh, I'm saying perfect. There it is. And I was also missing it on this one. Okay. And yeah, so I think we should be good with this. Why am I getting another one? Non-void function does not return. Oh, well, true. I want to return files in here. Think that's so. I'll just go through the algorithm again in case we're missing something. Um, so first, we want to check if the head is not null because we want to complete this edge case that is basically that we don't have any elements on our linked list, and that will be false. So this is straightforward. It's just a like a separated if from our algorithm. Then we have to create the two pointers on our head that are fast and slow. And then we want to check if our fast node and the next node of fast are not null pointers to continue our condition true for our while loop. We want to move slow by one step by doing this. And then we want to move fast by two steps doing this. And in case both are the same, then we want to return true because that means we have detected a cycle. Motivated here we have detected a cycle. And then just return false because it is the default return type. So I think it's good. I will run the first cases to see if we have any further. Oh, that's okay. That's good. I think it was fast enough as we are using pointers. That's always a really nice approach. And I mean, as we can see, this is more this is much more shorter than all of the description that I was explaining over here. But sometimes, at least for me, it is like more helpful if I try to explain like everything all at once, like in my notes, and then just going back to the algorithm, like just step by step. And as we can see, it's just like three main steps. Check if there are no null elements, create our two pointers, move one step, move one two steps, and then return if we have a cycle. So I think it's good. I don't know if you, Alberto, have any opinion or another, perhaps another approach for this problem.
Actually, I was thinking how to do this on JavaScript, but well, for C++, I think your approach is right. Like the thing here is some things you have to translate from one language to another. But yeah, as you mentioned, the answer was really fast and the test case was good, so why not?
Yeah, I wouldn't know how this works in JavaScript. I mean, at least I love that C++ has like this. It's just like very nice. Like, oh, I want to move to my next node. Well, I will just like point it with a nice arrow, like to move to the next one.
Well,
Yeah.
we have that question from JTreak, but the thing you mentioned, like how you do it on JavaScript, you could do different approaches yet. And yesterday I was mentioning, for example, the all in JavaScript are objects. So even you can create things like this about just pointing to the next state or some things. But also that's why a lot of people use like extension libraries about states, for example, Redux and stuff. If you work like with more frameworks, you can take also React, RxJS, which makes them reactive, things like that. But yeah, so just was extending the question there. We see this about the React. You want to answer that?
I'm sorry, I want to what?
You want to answer the React questions
Oh,
like
yeah, I read the comment. I mean, at least I wouldn't say that I use like C++ as my usual like language. I just basically use it for only for interviews, like 100% just for interviews. And I usually just use like Geeks for Geeks as a source, as a main source. Like they have everything you want to know, like over there. Like everything you possibly want to search about, it will be on that page for sure.
Yeah. So you want to try to see if that passes all test cases?
Okay. Let's go. It's taking time. It's definitely taking time. I think it would say like time limit exceeded. Oh no, it didn't. That's perfect.
Maybe it was internet too, because we're having kind of connection troubles here, right?
Yeah, we were both having connection issues. But yeah, here's the explanation. Nice little code. And I will stop sharing my screen now. There we go.
Nice. So I think it is my turn now. And I can start sharing mine. So here we
Oh,
are.
Alberto, wait. Before you start, I'll say goodbye to everyone. I don't want to
Yeah.
interrupt you in the middle of your solution, incredible
Nah,
solution,
don't
I'm sure.
worry. That's okay.
Yeah, because I have to sleep early. As I mentioned, I have an interview tomorrow. I'm very nervous. But let's see. I mean, sometimes it's just about of luck, like the problem that they ask you. So let's just hope that the question will be straightforward and easy to solve.
Now
Let's hope for
you
the
make
best.
yourself your luck. So um, help me everyone to wish the best of lucks to Jocelyn, and let's hope the best for tomorrow. You will rock it.
Yeah, you will receive updates about my status on our last stream of how did it went. Perfect. Bye
So
everyone.
nice. Thanks a lot. Cool. And thanks you for all the nice comments here and all the good vibes for Jocelyn. You're the best people. So let's start with this. I choose these not because other reason, but I did find interesting the name, like Queen's Attack. Then I opened it and I realized it was something about chess, and I mean that's completely fine. Still very interesting. So let's start reading this, right? You will give be given a square chessboard, like all chessboard, I'm guessing, with one queen and a number of obstacles placed on it. Determine how many squares the queen can attack. A queen is standing on an n times n chessboard. The chessboard rows are numbered from 1 to n, going from bottom to top. Its columns are numbered from 1 to n, going from left to right. Each square is referenced by a tuple, describing the describing the row and the column where the square is located. Okay, so tuple starts row and then column. The queen is standing on a position like the coordinates uh, RQ, CQ, row queen, column queen. In a single move, she can attack any square of the eight directions: left, right, up, down, and the four diagonals. In the diagram below, the green circles denote all the cells the queen can attack. Okay. Nice. If it's position on a 4 comma 4 coordinates on a 8 times 8 square scenario, the chessboard. Okay, are we getting this right? Um, I fear questions that make us solve board games like chess, Sudoku, etc. I can never get past brute force approach. Okay, let's see if we can make these like more efficient. If not, there's nothing wrong with the first solution of brute force. Of brute force. Same says here. So don't worry, we'll try to figure this out. There are obstacles on the chessboard, each preventing the queen from attacking any square beyond it on the path. For example, an obstacle at location 3, 5 in the diagram above prevents the queen from attacking cells. Okay, the rest of the cells 3, 5, etc. Given the queen's position and the location of all obstacles, find and print the number of squares the queen can attack from her position in the board above. There are 24 such squares. Okay, so the chessboard, I think it's not going to change. That's a good thing because I actually thought that would be dynamic. Function description. Complete the queen's attack function in the editor below. Queen's attack has the following parameters. It received numbers of rows and columns in the board. So yeah, I do think they are going to change the number of obstacles in the board, the row number of the queen's position, the column number of the queen's position, each and where the obstacles are located. Nice. Returns. This should return the number of squares the queen can attack. Input format. The first line contains two space separator integers and k and the length of the board's side number. The line contains okay. The first line contains two space separated integers n and k, the length of the board side and number of obstacles. The next line contains two space separated integers r and c. That's the queen's position. Each of the key lines contains two separate integers r and c, the row and column positions of the obstacle. Now the constraints are real numbers less than a million. A single cell can contain more than one obstacle, and there will be never an obstacle at the position where the queen is located. Okay, this is important, and this one too. A single cell may contain more than one obstacle. Then subtasks for 30% of the maximum score, for 15% of the maximum score. Um, okay, nice. And we receive a simple input and a simple output explanation. For example, here, 4 it's the dimension of the board, 0 it's no obstacles, I'm guessing. Uh, let's again check the inputs. The following parameters and k. Yeah, and the number of obstacles. Then the queen's position. So the queen's position is on 4, 4. Okay, nice. And the last thing we're missing it's the obstacles. So I'm guessing because in k it's 0, the obstacles no, well, doesn't make sense to mention that. And the sample output should be 9. Let's prove that. 1, 2, 3, 1, 2, 3, and 1, 2, and 3. Nice. Then, sample input will receive 5. That's the dimension of the board. 3 obstacles will be found. For 3, it's fourth row, third column. That's the position of the queen. Then we receive the first location for the first obstacle, 5,5, the second location of the first obstacle, the, the third location of the obstacle. Okay, nice. And the sample input. In this case, we'll receive 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, I think I understand this now. Like, okay, what I will do to resolve this, it's first trying to divide the whole task in more simple functions. And with that said, my first thought is trying to divide it into functions. One that trying to look for all the cells the queen can attack based on the queen's position and the number or well the size of the board, and that also can be divided in the movements they mentioned, the 8 movements the queen can do. So we can attack left, right, up, down, and all the corners. So we can say clockwise, up right corner, lower right corner, lower left corner, and upper left corner, right? So based on these, we can try to do all the mathematics and stuff. I think of these like matrices. So maybe Python can be better for that using Matplotlib or MATLAB. Sorry, Matplotlib, NumPy, or using directly MATLAB. But we are JavaScript users, right? So let's do that with JavaScript. So let's look for the function we can modify, which is this one. So complete queen's attack function below. The function expects to return an integer, the number of cells the queen can attack. The function accepts the following parameters: integer n, k, r, c, and the obstacles. Nice. So um, let's try to do something like Jocelyn good practices to saying how she's going to solve this. So divide problem into first count the number of cells queen can attack without obstacles. So let's start by creating um, let me think first if it makes sense like to do matrices for this or directly just because we can create So, for example, if this were the example, 4,4. So we know the dimension of the well, the size of the chessboard. It's 4 4. So there is it squared. So that's the value of n. That's no problem with that. And we can define function move or attack left function attack right. Another function to attack up, function to attack down. But what does this is going to give us? The number of additions in that. 1, 2, 3. If this should receive okay. I think I have the idea. So what we need to do is start checking, and I'm going to do this clockwise. So I'm going to take better this example. Well, no, they give us what's the okay. No, they don't give us that. Simply input one. Yeah, I'm going to use this one. So I'm going to start check clockwise, like the position, uh, and I'm going to make let number of attacks. And this will start in 0. And I'm going to make another thing that's const possible movements, and these are 8. And so the first, it's going to be up, and this will check for possible movements for let e equals 0 when e less than the possible movements and e increasing. What I want to start to do is rotating, and checking for the position. So let's do another thing. That's store these two. Well, now it doesn't make sense to store these two on some kind of constant. Um, well, maybe yes. Q for call. Okay, I create the object of that. So where the obstacle position given. The obstacle position given are here. This is an array containing the positions. It's a two-dimension array, but we are not getting to that yet. We first want to get like all the cells, and then we can start subtracting the positions here. If they found like an obstacle in the way of the attack, then we stop the sum of the movements, right? Yeah, okay. Well, that's the idea. So um, from here, from queen's position, we're going to start checking for n for let k equal to queen position dot row, well, dot column k less or equal to n k plus plus and number if what this is going to do is start checking upside. Yeah, this is the up attack. I'm going to check for ups, but this will not be later. Right now, just make number of attacks more equal to number of attacks. Right. So this this just was for the first movement. The second movement, yeah, actually, I don't think I'm keeping the movements. Now that will be diagonal. Um, diagonal up, right. For I think maybe a while approach could be better. Mm, let's start from this. Yeah, maybe while. Mm, mm, mm. I'm going to create something that it's going to be const counter position. At first, it will be it will have the same values as queen's position. So while counter position dot row, no, dot column, it will be less or equal than n. Now number of attacks can do this. Perfect. Yeah, and here one counter position dot column. Oh well, we need to do something else here. We need to set counter position dot column and increase, you know, +1. And there, after this, we need to set the values again. Number counter position dot column has to be less or equal than n, and wait, For example, the counter will be for 3, and I increase road. This will be okay, yeah, and counter position dot row same has to be less than n. In this case, we are going to increase same the row and the column. Actually, what I'm thinking is that what I need to do to make this better, it's like looking for a object oriented approach, uh, but that will be for improvement of the code. Like, I mean, I can do this without that. What happened? Why is this expected? Uh, oh yeah, I write this. This were while. Yeah, nice. What else? What else? I increase this too. I have this here, and the only thing I'm missing. Well, at this point, the better thing to do it's to directly. Okay, okay, nice. Now, what we want is the right attack, and we want something like this. But what we will want is the counter position dot row to be less or equal than the other, the counter position dot row to increment, and then we set these values again. Nice. Now the left diagonal down right, so it starts with counter position to be column, for example here will be returning to be, oh yeah, the column will be increasing, so no problem with that. The row is the one that will be decreasing here. And I think the best approach here, instead of this, will be set different than n. Same here, while this is different than n. So both are different than n. And I'm thinking of changing that too in these other ones. Like if the counter position column is different than n, for example, this starts being 4. Now this starts being 3. Oh, and then if I go up, this is not row column, this is row. Yeah, my bad. And this is row 2. Yeah, so 4 different than 5. Yes. So now I increase it, I increase it number. 5 different than 5. No. Okay. So then number counting. Return this. Column 3 different than 5. Yeah. And column and row 4 different than 5. Yes. I increase both and I increase the number of counts. So the next time, column 4 different than 5. Yeah, but row it's not different than 5. Row it's already 5, so that makes sense. Just one count more, and we return these values to 0. In this case, this is to column different than 5. This column is 3, so it will count 2 columns. Performs these. Now different counters position column will be different than 5 because the column is 3 and position it's and row 4 will be different than 5. The column for their left diagonal, right down diagonal, sorry, will be increasing, but the row will be decreasing until it reaches this point. That's good. Hmm. But be what it can't be 5 is the row them different than 1. In this case, I thought, okay, here for example, okay, imagine this is like diagonal down left. That's the next one, right? So counter position will start in column number 4, column number 4, different than 1 column will be less the next time. Control position row is different than 1, so both will be rested 1, and we have 1 count. So next time will be 3 and 3, both different than 1. We count, and then well will be 2. Here are 2, both different than 1. Yes, rest, and that will be the third. And with that said, the next time it's there are in 1, so no count for the next time. That's okay. And just let me prove manually here, for example, that this works because this is not going to count. It's already in the last position, so nothing to attack up there, nothing to attack to the right, nothing to attack on the right diagonal, because I mean it's already on the last column, but also on the, well, yeah, no, the thing is here on the column, the row it can be. Nice, nicely done. So next thing will be um, down, which I can copy the up. Now attack, that will be row instead of more or less. Diagonal, I can copy now the right, and it will be, oh, now in down there is also no this one, but this one, nice, diagonal, it's there, right, same, this will be left, this will be 1, and this will be less. We're almost done. Now just left, no, left, up, diagonal, up, left. That will be for the column, will be returning. So the column will be here, but the row 2 will be added. So for the row this again it's n, and yeah, that's it. We have our 8 attacks. 1 up attack, 2 diagonal up attack, 3 right, 4 diagonal down, 5 down, 6 diagonal down left, 7 left, and 8 diagonal up left. Nice. So no need to return that to the pointer. Console dot log number of attacks, and we can return that number of attacks. Okay, I want to see how this behaves. The book output says 0. Um, Okay, for example, for this first taste case, why I don't know why this didn't count any time. Okay, let's debug that. The values are N it's 4, RC it's 4 and 4. So this is the case, right? So no, nothing to be worried about. I mean, that should be passing. These possible movements, I can delete it. This queen position, I can delete it. So counter position dot row, it's 4. Is it different from 4? No, so no count here. That's okay. And we return the value to 4 just in case. Column, it's 4. Is it different from 4? No, so no need to check either the other. Return the values just in case. Column, it's 4. Different from 4? No. Okay. Column, it's 4. Different from 4? No. Again, no, it doesn't matter to check. 4 different from 4 from 1? Yeah, this should be happening like right now. But for doing that, we can inspect. That's why console logs are, isn't it? Counter position. Yeah, row and column, 4 and 4. Don't know why it's not counting. Like here, these 5 movements should do it. Okay, let's see something. Let's open again. Oh, you can open like a little terminal very quick just to see. Um, oh, I think this is not being shared. So give me a second. Sorry. Yeah, I was checking in my terminal, like why these were not working. For example, here it does, like it makes sense. Oh my God, I'm doing a very dumb thing now. I realize it. I'm I'm adding 0 to 0. That this should be one. Yeah, this should be one. 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 And this should be one. Yeah, of course. And let's remove this. Doesn't make sense. So it's supposed to pass the first test case. Yeah, the sample test case, because it doesn't count um, the the objects. But now we need to validate if there's an object on the way of the road. Then stop the while there. So how we do that? It's really simple. We need to start validating. If well, actually, it's not that simple because there's a lot of these obstacles. So let me think. Mm, we need to make sure that if there is an obstacle under this position, we stop the counter. But how do we make sure there is no? Okay, yeah. Let me. I want to log how the obstacles object looks like. So let's run this code. Okay, for this one, it should look like an empty array. Yeah, of course. For this other one, uh, okay, I thought, okay, yeah. For this case one, it's first element, second element, and third element. Okay, nice. Nice, nice, nice. Obstacles dot for each obstacle. Okay, no. Wait. I think I better do another thing. You can think this is the same, like doing for each and doing a four, but I want to break the while, so that will help me do more doing a four. Let e that e it's less than k, and that e increments if obstacle e. And now here I need to fix it to be zero, the first element. Uh, the first are columns and then rows. Row, row number four. Yeah, and column number. Yeah, so then first rows and then the columns. If row equals counter position dot row, if the first obstacle has this and like the second obstacle. Okay. Mm. Let me check just in Mozilla ambient while loop for that breaking while JavaScript, of course, that's what I want. Exiting the while, condition, statement, description, break, yeah. Stop statement execution and goes to the first statement after the loop. Uh, yeah, I think what I want is continue. Um, but let me check if that's inside of for. Does that affect? Okay. Yeah, maybe it is. It does. So I'll need to save a flag here. that says this actually it's on the way of the counter, because how it works, it's I'm here and then I pass here, that counts. I'm here, then I pass here, that counts. I'm here, then I pass here, that counts. Then I pass here, I count. Then I pass here, I count. Pass here, I count. I'm here, then I pass here, I count. It counts. But if for some reason now I'm here, I have to check if any of these ones has an obstacle. Like I need to be able to check for obstacles here on every one of these. So how I do that will be to do this. If look for obstacle returns true, break. I don't want nothing else. Okay, we can try this, but it needs to be added to all of these functions. Okay, okay. It counted 14. Why? 1, 2, 3, 4, 7. Okay, it's counting all of them. Of course, there's no making a break. Let me do something quick. Make break. Oh, make break. Okay, let's see. What? Where are my output? The book? Oh yeah, here it is. All are false. Why is that? Let's imagine this case. So we came here and we need to understand what's happening. We set the make break false variable at first, then for the number of obstacles that we have, we check all of them. If they are uh, the ones are we are looking for, so we are going to console log all of this. So we are going to console log obstacles, counterposition, obstacles, and counterposition column. That's what we are going to do. What? This is not even displaying. Oh, I never initialized this. Ho ho ho. And I'm kind of hoping that, yeah, this one find, yeah. So we found two inner ways. That's for the uh, 1, 2, 3, 4, 5, 6, 7 movement. This one not. This one, I'm kind of worried because I thought this one's the one that it was supposed to find it. Like, so I have it 1, 2, 3, 4, 5, 6, 7, 8, 9. Why I have this obstacle more than we're just calling this 9 times, 8 times even. So why it's not that much? So this much. Why? 5, 5, four two 554223 554223 554223 554223 554223 Oh, yeah. I think I know why. Because these are loops. Of course, yeah. No, no, sorry, but that's perfectly fine. Like that's okay that it's called more than one time. What it's happening then now, and the only thing we now need to correct now for having this done, it's that the break performs or still performing the addition here. Uh, yes, in this case, stop statement execution and goes to the first statement after the loop. And that's why we're counting these ones here, because even when this happens, well, I think what I need to do, it's not only break, but number of attacks less one and break. Well, to not move that much, I can do that here. Since this global, well, not global, but accessible since this function. Yeah, that's what we needed. Let me now look how we can improve this code because feels kind of dirty. Again, I will kind of prefer doing object oriented here because all these can be easily converted in methods of the instance, and the reset we're doing here, we can convert that also as a method of that. But well, what we wanted and what we achieved on time, it was to complete this. Like I feel confident that if I submit it completely, it will pass all the rest of the test cases. Just let me. Just did that because I wanted to debug like the outputs. Oh, here it's not happening that. Well, it doesn't matter. I can return to what was done. And well, let's submit that. And yeah, all test cases are, well, seems to be correct except for these two. They are taking its time. Oh, they fail. Whoa. Okay. You have earned your first. Okay, there here time was X there. Here time limits. Okay, yeah. So, uh, we passed from 21, we passed 18. So, well, from 22, because we have a zero here. Yeah, we passed 22. So we could improve major things here around, for example, the accessing of these variables, the times we are iterating over these loops, and it stop them once we look for. No, well, to be honest, I'm not sure how we could stop them. Maybe there are other approaches, but for this one, yeah, brute force. The those not. I don't know. Like, could we do any other interesting thing for performing better? Probably we do. Like, I'm sure we do. But right now, you understand like the code. Like it's always this mental process, how I do it myself. So if I have to start where the queen is, I will put a counter, and I will be counting how many steps can I take until I reach the edge of the board, or until I reach an obstacle, and that'll be it. And I will do it clockwise, because simply because I just decided that, because I think I like it. It's natural, but I could also do it like anti-clockwise or randomly, or whatever. But the point is, I get the results. Not in time, apparently, for three test cases, but hey, it was something. And we are running out of time here. So, thank you a lot for joining. And this was a medium ranked problem, and let's see how we can manage a more difficult one. One tagged difficult. Actually, the approval for this one was 67, 60 something. So I think we are in good position here. Don't know what I did. Huh. Max score is 30, and I got 26. So that was not bad. Well, we got 26. There were statistics about submissions. Discussion. Leaderboard. Python solution for this. Yeah, they also did this kind of stuff. Well, very more clean way. Yeah, they manage the directions. That this how. Well, I didn't want to show this. I wanted to show. Okay, implementation. Yeah, here. This one's the one we did. So it's around 70% of success rate. So we're in that 70%. That's nice. Thanks. And that will be it. Next, we will be trying a hard one. Uh, Actually, there is only one labeled as hard. Um, but yeah, rotate the matrix or times and print the resultant matrix. So let's see if this is worthy, or I will try to have any other around lead code, or something. So see you on Wednesday, people. Thanks a lot for joining. Bye.